Hello friends, this video on alcohol, phenol and ether part 23 is brought to you by examfear.com. No more fear from exam. We'll see the next reaction called Cope reaction. Here we have this phenol, you have this carbon dioxide and you have sodium hydroxide. You get salicylic acid. This is what you get. So let's see the reaction here. So I have my phenol. I react with NaOH first. I get ONA. This reaction we have seen, right? OH bond breaks. Correct. Now I react with CO2. What I get is and H plus, what I get is salicylic acid. I'll give you the reaction mechanism very shortly. See, sorry, here only you can write OH, COOH. This is what you get. Let's see the mechanism now. So let's see the mechanism. So in this mechanism, what happens is this is my OH, and when you react with NaOH, what you get is ONA, right? This is reaction we have seen. Correct? So ONA is nothing but O minus, I can say, because it's O minus Na plus. So this will go for a rearrangement actually. Rearrange. So what it will happen here is, if you see this O minus, if I form a double, this bond if I breaks, I'll show you once again actually. Let me show you. Correct. So if I break this bond into plus and minus like this, I'll get a double bond here. Correct. So let me do that. And this will be my negative charge and this. This is obviously H here. Correct. Now if I react this with CO2, what will happen is, since there is a negative charge, so what will happen is it will go in this direction. It will get a positive charge, this get a negative charge, right? And this positive negative will form a bond. What you get here is, this reaction is something. CO minus double bond. Perfectly fine. So if you see, this goes in this direction, minus plus, plus and minus combines to form a bond. Correct? But we broke the aromaticity. We want it back. So how can we get it back? So to get it back, what we can do is, let's break this bond actually. So what we can do is we can kick this hydrogen out, right? We'll get a negative charge here. H plus will go out. And this is negative charge here. I want a positive charge here. So I'll make it in this, break this bond also, this bond. I get a positive charge here, I get a negative charge. Correct? So with this, if you see, what happened now is, with this positive negative can form a bond. This will become O minus. This H is gone anyway, and this I am left with O minus. Correct? So this H which was gone will now get in touch with this minus. Correct? And one more H plus, H which was gone here, will hit this. There will be two H actually. So with this, what you get is, this becomes OH, this becomes COOH, and this is my salicylic acid. Hope you understand the mechanism. This was O minus, it went for a rearrangement, and with that I got a negative here. My carbon could easily attack, forms a bond, but again I don't want to break my aromaticity. Again, reshuffle things to bring my aromaticity, and this I got 2O minus here. In that my H plus attacks, and then you get this reaction. So the next is Reamer-Tiemann reaction. So let's see this Reamer-Tiemann reaction. What happens here is you take this phenol, you react this with chloroform and NaOH, and whatever output you get, you acidify it, and then you get this guy. You get OH with CHO here in the ortho position and OH with CHO in para position. Correct? Hydroxybenzaldehyde. Let's see the mechanism here. So the mechanism is, first we have CHCl3. I have CHCl3. In this my OH minus attacks, right? This has more electrons, attacks. It pulls that hydrogen. So what I'm left with is this is minus H plus with the plus charge. Since there is a plus charge here, I want to get rid of plus charge. So it will be negative charge because this OH minus. So if you see the way it works is this OH minus will attack this carbon actually, right? And then it will pull this hydrogen. So overall, there's a negative charge induced in the system. So this carbon will get a negative charge. See, this bond will break in this fashion. Correct? So if you see, or you can say that this bond will break in this fashion and this OH will attack this hydrogen. So it will be H plus and OH minus will form water, and this bond will break and this carbon will get a negative charge. Hope you understand. This bond will break, this will get negative, this will get positive. This positive H plus and OH will form water, and this carbon will left with negative charge. Now to get rid of negative charge, I don't have any acid here, any H plus to compensate. This chlorine will say, okay, I'll go off. This chlorine will go off. So with that, what you get is carbene. This is a carbene, right? It's a chloroform carbanion actually. This is unstable. This is also electron deficient. It's very, very unstable. Now let's see this reaction. Now I have my phenol here. Correct? Okay, this is my phenol. And first thing I do is I react with NaOH. So I get ONA actually, and that is nothing but O minus. So let's form O minus. Correct. Now O minus, there's H here obviously, H everywhere, but I'm just putting this H because I'm trying to have reaction here. So let's form a rearrangement of this. So what happens is this bond breaks in this fashion. This gets negative charge, this gets positive charge, positive and negative forms a double bond. Right? It's negative charge, hydrogen, and this. Correct? And you see this is the electron rich site. Correct? Now what happens is this guy, carbene, this is electron deficient, right? This will attack. Correct? Because this is electron deficient. So what will happen here is we'll get something like this. Wanted to form a bond, it formed bond, good. This is H, this is C, Cl, Cl. Now if you see, the aromaticity is broken anyway, right? So we want to retain back the, this is a negative charge here, sorry, yeah. We want to retain back the aromaticity. Correct? So what we can do here is, if we ask this hydrogen to leave and join this carbon, anyway carbon if you see has one more bond left. Correct? So let's first form a double bond here. So let's put a positive charge here. To put a positive charge, let's move this electron in this direction. There is a negative charge, this is a positive charge, or it's when again will form a bond. Correct? Bond. Aromaticity is back. This is O minus. this is H, there is C, Cl, Cl. Correct. Now if you see, this carbon has now 1, 2, 5 bond. It can't have, right? So one has to go. So this hydrogen will go, and this is carbon here. This hydrogen will go and will join this guy. Correct. So this hydrogen bond will break now, and this will join this. So with this, the aromaticity is still there in O minus, and you get C, Cl, Cl, and H. Correct. So everything is maintained now. Till this point is clear. Now what I was doing is we are adding OH minus here again. To OH minus. That will replace this chlorine. So what you get here is, instead of chlorine, I get OH, OH, and H. Now if you see, in one carbon I have two OH group, definitely water will come out and double bond will be formed. You say minus H2, what you get is this guy, O minus COH. And on this you just add a H plus. It will take care of O minus, and it will form something like this, OH and COOH. Correct. And this is called salicylaldehyde. Little complex reaction, but first thing is it will form unstable carbene, and then we'll get a negative charge center here. Since electron rich center is electron division, there will be a reaction here. It will form something like this. Here also it has one vacant thing actually. 1, 2, 3, 4. Vacant. And then this will form here. This will come here. You'll get something like this. And then chlorine, you replace chlorine with OH, you get something like this. Remove water, you get this. I think there's a small mistake here. See, when this forms a bond, right, the negative charge has to go to carbon, not with hydrogen. Correct? You see this bond getting formed, this negative charge is a lone pair of electron, so this will form a negative charge here. Since this is a negative charge, this hydrogen will pop in and want to form a positive charge, right? So hydrogen will come out of this and join this actually in the next reaction first. Okay, let me cut this part. So let me first move hydrogen here. This bond will break, correct? And then it will have a negative charge here, and this charge will go off. So with this, what you get here is this. Let me draw it somewhere here. Okay, so let this be double bond only here. C, H, Cl, Cl, and now this guy will get a negative charge because this bond broke, plus and minus. So now this guy will have a negative charge. And now what will happen is this bond will move in this direction. Negative and positive will form this compound. Correct? Back to aromaticity. A small mistake here. Correct. Thank you. Visit our website examfear.com to watch more and more quality education videos. You can also attempt free online tests that are there in our website. You can also get access to tons of free study materials, and you can also find free tutors and mentors in this website. Thanks a lot for watching.